problem of the day, maximum selections. Geek wants to select the maximum number of course bundles at the Geek Summer Carnival. You are given a finite number of courses and n range of numbers, each depicting a bundle of courses. Select the maximum number of bundles such that no courses overlap in any of the bundle. So this statement actually means we have to find the maximum number of non-overlapping. Okay, maximum non-overlapping, that's what we need to find. So we also given a note, the ending of the range being the same as start of another is considered as okay. If the end and the start is same, so it's not considered as an overlap. So let's have 1 5. Let's check this. We have, let's consider like this one. We have 1 5. Okay, 2 3 2 3. Okay, and we have 1 8 1. Let's have 8 here. 3 5. Yeah, 3. Oh, we already have 3 5. 1 5 2 3 1 5. Okay, so we have 1 5 here, 1 here, then we have 2 3 this part, we have 1 8, well this 1 8, and we have 3 5. Yeah, 3 and 5. Okay, so the idea what we are going to do here means, like we have 1 2, no sorry, we have 1 5 2 3. Okay, 1 5 2 3, 1 5 2 3, 1 8 and 3 5, 1 comma 8 and 3 comma 5. We will be sorting in the increasing order for the second number with the end number. Let's say this is start, this is end. We will be sorting the given 2D array with respect to the end number. So when we sort this, our 3 will come first, and this will be 2. So 2 comma 3, and the next number is 5 1. Okay, that's pretty cool, 1 and 5, because even if the start and end is same. Okay, so 1 5, then let's have 3 comma 5, and 8 is the largest among them, so it will be the end. Now let's have our some virtual end, which is currently pointing to minus infinity, a very small value. Okay, now we go through this sorted array. This for every non-overlapping problems, this is the way to go. First we have to sort the given input array based on the end time or the end interval. Then we will be having some virtual end. Okay, virtual end, and it will be some small value, very small value. And now we also need the counter. This is the result, and this will be the counter. So at first we have 2 3. This is the start. Okay, this is the start, this is the end. So is the start is greater than the virtual end? Yes, it's greater, so we have 1 here. Okay, so now our virtual end is updated as, what is this? It will be this end 3. Okay, so that is not overlapping. That means this is not overlapping. Now now our virtual end is at pointing at 3. Okay, now next our point is 1 comma 5. Fine, 1 comma 5, is this 1 is greater than or equal to this 3 with the virtual end? No, so we just skip this. Now we move to 3. So is this 3 is greater than or equal to this 3? Yes, perfectly fine, it's greater than or equal to that 3, because it's stated in the question is that the ending of the range being the same as start of another is considered as an overlap. So even though the start and this virtual end or the current end, whatever it may be, even if they are same, like we are not consider them as, yeah. So what we get, this is also a non-overlapping, and we will be updating our virtual end to be 5 and our result to be 2. Okay, now we have 1 comma 8. Is this 1 is greater than or equal to 5? No, 1 is not greater than or equal to 5. So we will be returning this result at the end, and this is the number of non-overlapping interval in this state, and it will be 2 comma 3 comma 3 comma 5. So that's the way to go. Sort based on the end number. Just maintain the result variable. Just maintain some current end or some virtual end, which is initially having a very small value, and whenever we are having the start value greater than or equal to the virtual end value, that means we are having a result. So we increment the result, then we update the virtual end as the current intervals, the whatever will be the interval that we are traversing, or the what we are standing, that end will be replaced with that value. Then the process continues, and that then whatever will be the value remaining at the result will be the answer. So that's for the first example. Let's also go for the second one, the same approach. So 7 comma 9, 2 comma 8, 7 comma 9, 2 comma 8, 1 comma 3, 1 comma 3, 10 comma 11, 10 comma 16, 10 comma 11, 10 comma 16. So what is our idea? We will be sorting these values. Okay, we will be sorting these values, and suppose this is start end. Okay, so which is the smallest value? 3. So 3, 1. Okay, we got that one. Now next largest value is 8, so 2 comma 8. The next largest value is 9, so 7 comma 9. Okay, perfectly fine. Next one is 11, so we have 10, 11, and next one is 16, so 10, 16. So now what is our next step? We will be having a result which is currently 0 and a virtual end, okay, which is minus infinity at the initial stage. So now we start. Is our start greater than or equal to minus infinity? Yes. So our result is 1 and our virtual end is updated as 3. Okay, it's fine. Now we move to this 2. Is 2 greater than or equal to 3? No. So we are not updating our result and our virtual end. We move to 7. Is 7 greater than or equal to 3? Of course, it's answer. So we update our result as 2, and this value will be updated here, so it will become 9. Now we move to 10. Is 10 greater than or equal to this 9? Yes, of course. So our result becomes 3, and our virtual end will be updated with this value, so 11. Now we move to this value, so this is also possible, this is also possible. So 10, 16. Is 10 greater than or equal to 11? Of course not. So we got end of the loop, or the end of the array. So what will be the value here? It's 3. So 3 is the answer. So let's reconfirm that. Yeah, 3 is the answer. So pretty straightforward. We can make use of the comparator in Java along with some lambda functions in order to quickly sort the given 2D matrix with respect to the end value. So it's done like this: arrays dot sort of ranges, and we are taking two values from here. Let's say range 1, range 2. So, and we will be doing the comparison, integer dot compare of the second value. It will be range of 1. Range of 0 will be the start value. Range of 1 will be the end value. We need to sort based on the end value. So range of 1 and range 1 of 1 and range 2 of 1. So now we have our sorted values. Now let's have non-overlapping equal to 0. Let's have int a virtual end which is equal to a very small value, so integer dot mean value. Now just go through the sorted ranges matrix or the array. So for each of the range from ranges. Okay, what is our current start? Our start from will be range of 0. What will be our current end? It will be range of 1. So what was our condition? If our current start is greater than or equal to virtual end, the non-overlapping increases and we update our virtual end which is equal to current end. Otherwise we do nothing, we move forward through the array and finally return non-overlapping. So here we are actually sorting, and if the length is n, so the total time complexity will be big of n log n, and space complexity will be big of 1. Actually for this sorting, actually there can be a big of log n space complexity, but let's do not consider that here, and we can say that the space complexity is big of 1. So I have a compilation error. Integer dot non-overlapping integer dot compare. Let me check it. Variable I. Sorry, it's 1. Simple mistakes. So we are getting to 2. Let's submit it. So that's a problem of the day. Maximum selections. It's just finding the maximum non-overlapping, the count of maximum non-overlapping ranges.